All right, we're at chapter 32, alternating current circuits. Let's share the PowerPoint, and they give you a story about checking um, an extension cord with this little device. You plug this device into an extension cord, check it into the wall, and you notice that the lights look a little different when you see movement on the device, and you swing it around. I wouldn't recommend anybody try this, but when you swing it around, you see the lights flash off and on. And this is an effect that you see uh, if you've ever tried to photograph uh, Christmas lights, the LED Christmas lights, and there's any kind of movement with your camera, if the exposure is long enough, or if you can set it for a long exposure, you'll see that the lights do indeed flash off and on. I have a little video that I'll probably post separately. It's flashing light, so if those types of images bother you, I wouldn't recommend you look at it, but it'll be it's just an LED shop light that I have in my garage. You can very easily see that it flickers off and on. I just did that using the slow-mo mode on my iPhone. You can do the same thing. If you look at a light, you'll see a strobe when you view the slow-mo version of your video. Anyways, so indeed, the alternating current that we experience here in the U.S. is going, it's alternating back and forth, as you see in the graph. It's positive for half a cycle, it's negative for half a cycle, it's positive for half a cycle, and then negative for half a cycle, and it just keeps repeating that. So the rate, the alternating current rate here in the U.S. is 60 hertz. I believe in some of the European countries, it's 50 hertz. And you can see here that the delta V, it's a lowercase v, that indicates it's alternating current. The delta V is equal to delta V max. That's the peak that it's going to reach on either side. Delta V max sine omega t, where omega is equal to 2 pi f, 2 pi times the frequency, or 2 pi divided by t, the period. Now here in the US, the 60 hertz, that gives us an omega of about 377 radians per second. So you can see that the period is from a peak to a peak, or if you want a trough to a trough, or a zero crossing to a zero crossing. Now, if you're going to measure zero crossing to zero crossing, you have to do it in the same direction. In other words, if you do it from this zero crossing to this zero crossing, you've only gotten half a wavelength. You have to do it for a full wavelength to get the period. So from this upgoing zero crossing to this upgoing zero crossing, or from this downgoing zero crossing to this downgoing zero crossing. So you need to make sure, it may be easier to do it from peak to peak or from trough to trough. Sometimes especially if you're looking for like at a pendulum swing, it's easier to do the zero crossings. Anyway, that's a little intro to AC sources. They alternate back and forth, and on a separate video, I'll demonstrate the flashing lights on a of my shop light. Okay, so we'll end this section.